All right, everybody, let's talk about rational functions. Um, let's see. So, yeah, let me just write that down. Rational functions. Now, if you're looking for extra information about this, you can also look up reciprocal function, and that'll also give you some useful results online. Um, Okay, so Paul rents a guest house from the landlord for $360 per week. In order to save money, I'm having a tough time reading that because I screenshotted this off of a YouTube video yeah, and divides the expense equally. Okay. You know what? Here, let me I think I've still got that video open. Yeah. Um, what does that say? He has other people stay and divides the expense equally. The formula that models the situation is cost equals 360 divided by n, where C is the cost per person and n is the number of people staying per week. So, so what does it cost him? Okay, well, that depends on how many people are there. The more people that are there, the more you divide up the $360. Clearly, you know, this is old data nowadays because this is actually pretty close to when I was going to college in the 90s. This is actually a little lower than that, but not much. Um, okay. Anyway, let's get rid of that. So that's kind of the idea there. So there's different things we can do with this guy. We can say, well, um, let's do the input output table here. I'm gonna do this the easy way because why not? 360 divided by, let's see, I need X on the calculator. So this button here. And let's see, then what are my settings here? Let's start at zero. Well, let's start at one person because that makes more sense. We'll go one person at a time. That's what the numbers mean. We're going to start at one person staying there, so just Paul, and then go up, one at a time, one at a time. I mean, you could say let's go up half a person at a time, but that wouldn't really be helpful. Okay, so let's go to the table, and we can see that, okay, when there's only one person there, when it's just Paul, it is Paul, right? Yeah, Paul, well, he pays all $360. If there are two people there, so he has one other person with him, now two people can split the cost, and it's 180 bucks each. If three people, 120, and so on. So, um, we could put that in there and say, we got that. Again, the function is C of n equals 360 over n. So when n is 2, then 360 divided by 2 is $180 per person. And when the number of people staying there is 3, now it's $120 per person, and so on. Okay. And the rest I don't remember. I guess I should go look that up real quick, huh? I suppose. Let's see. Right here. Let's see. Then it was 72 and 60. Okay. Got it. Okay. I'll write that down because that's what teachers do. $72 per person, $60 per person. So if he can get five roommates, so with a total of six people, well, he's only paying 60 bucks. Okay. And everybody else is, paying his mortgage for him or whatever. So that's pretty cool. All right. So we can make an input output table. And I know that often the input output table is vertical like this, but, it doesn't matter, obviously, if it's vertical or horizontal. Okay. Okay. So let's clear that out. All righty. Okay, so now let's talk about the asymptotes. Okay, and why is that button there? That's dumb. Okay, and let's change colors because I'm getting bored of that one. What is that anyway? Orange. Well, I love that. Orange is my favorite color, but that's a weird orange. Um, okay, so um, let's see. Are there going to be any asymptotes? Well, let's look at vertical asymptotes. Okay, for vertical asymptotes, those occur only when the denominator is zero. So denominator is zero. Well, in this case, there's no evaluation to do. I mean, because n is already isolated, so it's just n equals zero. So when we graph this thing, the let's see, the vertical asymptote is, we'll go back to that color, is going to be the line y equals zero. And normally I'd make it a dotted line, but Zoom, I haven't figured out how to do dotted lines on Zoom. So anyway, so the y-axis, that's going to be the vertical asymptote. And and so the graph, might look, I don't know, something like this. Maybe. I don't know. Okay. But I do know that the graph will not touch the vertical asymptote. It never does. It's like no man's land in World War One. Okay, remember that documentary they made a few years ago called Wonder Woman? And she ran her through no man's land. Anyway, it's kind of like that. So, um, so that is, kind of what's going to happen. At least, as the graph gets close to the asymptote, the vertical asymptote. Okay. What about horizontal asymptotes? Okay. Obviously, you can have more than one vertical asymptote. Like, for example, if you've got like y equals 2 over x minus 1 times x plus 2. Yeah, you can have two vertical asymptotes, and they would be x equals 1 and x equals negative 2. Okay. And then you'd say, oh, yeah, here at x equals 1, we've got one, and here at x equals negative 2, we've got another. And then, maybe the graph does something like this. Who knows? But it won't touch the vertical asymptotes ever. Okay. That's a no-no. Okay, so for horizontal asymptotes, let's see. Well, um, let's see. The degree of the numerator is zero because there are no x's there. And the degree of or n's, the degree of the denominator is one because it's just n to the one power. And so because the degree of the numerator is bigger than the degree of the denominator, there will be a horizontal asymptote, and it will be uh, C or Y, you can say Y, C equals zero. Okay? In other words, it will, wait for it, it will just be the line, the x-axis, the line C equals zero, Y equals zero. Okay. So that's what's shaken there. Okay. And again, if the degree of the numerator and denominator were the same, then you would say, like f of x equals 3x squared minus 2 over 6x squared plus 2x minus 1 or something. And then you would, if that were the case, if the degree was the same for the numerator and denominator, then the horizontal asymptote would just be y equals the leading coefficient of the top divided by the leading coefficient of the bottom. In which case you would have a horizontal asymptote right there. Okay. Um, so that's, a little bit more of what the heck we're talking about. Um, okay, so let's see that on the graphing calculator, shall we? Um, so x-axis and y-axis, those are the asymptotes. Actually, you know what? Let's just clear that stuff out, and then I think it'll be easier to see the calculator. Um, okay, we've already got it there. So I'm going to go to window. Because again, X, that's our N, that's the number of people staying. Well, we certainly don't need to go below zero. We don't even need zero. You're always going to have at least one. Um, well, but you know what? To really, yeah, that's fine. And I doubt he's going to have more than 10 people staying there. Again, X stands for number of people staying there. Okay. Well, now Y, that's the C of N. That's how much it's going to cost each person. Well, it's never going to go below $0. That would just be weird. And it's never going to go above 360 because that's the total bill to be paid. So let's see how that looks if we graph it. Okay. Oh, and I've still got, let's see, let me turn this stuff off. Okay, because I don't want it. All right, so you can see the asymptotic behavior of the function. Okay, as it gets close to the vertical asymptote, it starts going, and it just takes off and gets steeper and steeper. And as it gets closer to the horizontal asymptote, which in this case is, y-axis, x-axis, you can see it just gets flatter and flatter and flatter. Okay, you can see that more clearly if we zoom out. Okay, let's go back. Here, I'll just go zoom 6, and maybe that'll be good enough for now. Okay. It's off camera. Okay, let's try zoom 0. That'll change the Y min and Y max. Okay, there we go. And let's see, what did it choose? Oh, negative about 2400 up to positive 2400 roughly. Okay, that's fine, no big deal. But you can see more explicitly here the asymptotic behavior of the function, that as it gets close to, you know what, that is not the right color. Let's do this again. As it gets close to the vertical asymptote, which in this case is the y-axis, it gets very, very steep. Okay, right there, the function on both sides of it. And as it gets close to the horizontal asymptote, it gets very, very flat. Okay, and you can see that in the table, in the input-output table. If you look at that, you can say, all right, so um, so as x gets really big, okay, what's happening to the y values? Well, they're getting smaller and smaller, but they're not dropping that fast. Okay, let's speed this up. Let's go maybe 100. Let's go 100 people at a time. We're going to increase by. Now, of course, that's outside the domain, but notice what the y values are getting closer to. They're getting closer and closer to height 0. Those blue numbers, at least I think they're blue in y1, they're getting closer and closer to 0. So, because the horizontal asymptote is the line y equals 0, the x-axis. So it just gets closer and closer to that. Okay. Now, what about the vertical asymptote? Um, let me think here. Okay, so what if the vertical asymptote is y equals 0? So we want to, or I'm sorry, x equals 0. So we want to get close to 0 on the x-axis. Let's go 0.001. Okay, actually, you know what? Let's start off, I don't know, maybe zero point 0.1. So we'll start really close. Okay, I changed my mind again. I'm going to go 1 there and then delete that, and hopefully that'll work reasonably well. Okay, so at x equals 0.1, we're very close to the y-axis, very close to x equals 0. And notice, as x gets close to that vertical asymptote, as x gets close to 0, notice what's happening to the y values. They're getting bigger very fast. Whoops. Oh, a little too fast there. I guess I didn't do that as well as I wanted. Let me see here. 0.001. Let's try that. Okay. Oh. Oh, I'm doing it backwards. Um, okay. zero point zero 0.01. Delete. 0.01. Okay. Yeah, I was thinking about it backwards. Okay. So as we get close to y equals 0, notice what's happening to those y values. Okay, just those y values, they get bigger and bigger, faster and faster. And I mean, when you're only 0.02 away, you're at height 18,000 already. You move to 0.01, now you're at height 36,000. Whoops, I got to go over here. When you're at height 0.001, you're at 360,000. Okay, so it gets very steep and very high very fast. Okay, and on the other side of the vertical asymptote, it gets very small, hence the negative sign, and that's why you get so that's showing what you're seeing here. Okay. So when I was, looking at those numbers, it was, oh, look how high it's getting. Boom, boom, boom. It's just getting so high so fast. It's very, very steep. And then for a moment there at the end on the other side of the vertical asymptote, I said, hey, look, it's just dropping really fast into these very, very extreme negative numbers. So that's kind of what's going on. So what about the domain and range of this thing? Okay, I need a new color because again, I got bored of that. All right. Well, the domain, that's all the x values that are being used. Well, how about this one? Is -9 being used? Yeah. How about -7? Yeah. -2? Yeah. 1? Yeah. I mean, again, 1 is being used right there. That point on the graph has coordinates 1 something. Well, we already know it's 360. How about -2? Okay, yeah, that's being used. That's being used right there. That point has coordinates -2, -180. Okay, everything's being used except x equals 0. Okay, so we could say x is not equal to 0. Or we could do -infinity to 0 with parentheses, union 0 to infinity, and then that takes care of everything. Oh, not so fast though. Okay. If this were just a regular, function, it's like here's a function, there's no context. That would suffice. But there is context. Okay. Um, because again, the domain represents all of the x values, or in this case, the n values. And what does n stand for? N stands for the number of people who might stay at Paul's house. Well, you're not going to have negative numbers of people that stay there. That's not going to make any sense. So because of the context of the problem, the domain is just going to be 0 to infinity without including 0. Okay. And then you could come back and say, you know what? I doubt he's going to have more than 10 people there. I'm going to go with that. You could do that, I suppose, but like for a test or homework, this will be the way to go, 0 to infinity, because of the context. Without the context, you'll include this as well, because without context, there's no reason to get rid of it. All right, what about the range? Okay, the range is all the y values or c of n values that are being used. Okay, well, this y value is being used, and this one, because those each correspond to points on the graph. Okay, they'll all get used except for y equals 0. Again, this goes back to the asymptotes. Okay, hopefully you're noticing that. So if you know your asymptotes, then that really, really helps you to know the domain and range. Okay. Um, Alrighty, so anyway, so we would say, well, y cannot be 0. Or, in other words, -infinity to 0 and 0 to infinity. Okay, but then again, y stands for how much the cost each person has. Well, no one's going to have a negative cost. So again, by context, we're going to throw that part away and we're just going to keep this guy here. Okay. So that's kind of how rational functions work.